Hello there, AP Calculus final exam review video number 5. This is the last one. I'm going to work these optimization problems here. Hopefully it'll be my shortest video. Now these problems down here come from chapter 4. If you want to go back and watch me work almost all of these, they are in the Chapter 4 review videos that I've already made, and I actually worked several of the odd problems as well in those. So feel free to go look at those videos, but you just had that test, so hopefully that's fresh on your mind. Open up to, we are on page, excuse me just a minute while I find that, page 210. And we're going to work number 16. So 16 says a rancher has 200 feet of fencing with which to enclose 2 adjacent rectangular corrals. What dimension should be used so that the enclosed area will be a maximum? So I'll draw these corrals. We want to maximize the area. Alright, so we have x, x. You can also call this x, x, y, y, y. So what you want to do is get an equation for area. You have to have that because that's what you're trying to maximize. So area is going to be 2x times y. But we also need an equation that adds up to 200 because we have 200 feet of fencing. So that's going to be 4x, 1, 2, 3, 4, plus 3y is equal to 200. Okay, so what you need to do is solve for x or y, your choice, and then substitute in so we have an equation that doesn't have too many unknowns when we take the derivative. So I think I'm going to solve for, it doesn't really matter. Let's say 4x is equal to 200 minus 3y. X is equal to 200 minus 3y over 4. So x is equal to, 4 will go into 250 times minus 3/4 y. And we'll plug that in up here for x. You could have done it the other way and solve for y. I think that's the way when we did this for homework that I worked it, but it's good to work it a different way. So area is equal to 2 times 50 minus 3/4 y times y. So area is equal to 100 minus 6/4 y times y. 100y minus, and let's reduce that to 3/2 y squared. Now in order to get a maximum, we know we're going to have to take a derivative. So I'll do that down here. A prime would be 100 minus 3y, and we're going to set that equal to 0. Alright, so 3y is equal to 100. Y is equal to 100 over 3. So let's solve for x. Alright, so x is going to be 50 minus 3/4 times 100 over 3. So that's going to be 50 after the 3's cancel minus 25. And so our x value would be 25 feet and our y value would be 100 over 3 feet. So that is the dimensions that should be used to maximize the area. So it would be the total dimension, since there's 2x, it's 2xy to be 50 times 100 over 3 for the entire corral, and each pen would be 25 by 100 over 3. All right, that is number 16. You should, of course, maybe work some from work 15, 17C. Let's try number 22. So 22, I was able to blow this one up. So refers to this figure right here. A rectangle is bounded by the x and y axis with a graph of y is equal to 6 minus x over 2. What length and width should the rectangle have so that its area is a maximum? Okay, well, you know that the area of a rectangle, this is 22, you know that the area is just equal to the length times the width, or x times y. We also have an equation here that y is equal to 6 minus x over 2. Okay, so we could plug that in right there. Area is equal to x times 6 minus x over 2. So area is equal to 6x minus x squared over 2. So that would be 3x minus 1/2 x squared. Now let's take the derivative so we can get our maximum. So a prime would be 3 minus x. Set that equal to 0. So x is equal to 3. And then y is going to be 6 minus 3 over 2, which is 3/2. All right, just a quick little problem to kind of get you going there. Now let's take a look at the business problems. Okay, so I would definitely, before we leave geometric optimization, it says the suggested problems on page 210, 15, 17C, and let's see, 31, excuse me. You should work those. And if you have trouble on any of them, just let me know. But you should definitely work those, since I only worked 2 problems here. Okay, let's work the business problems, and then we will be done with this final exam review. Okay, so with the business problems, we need to write down our formulas. Okay, so the formulas for business, and you're going to want to put this on your cheat sheet if you're going to make one. Alright, so I'm not going to put all the ones that we used before because you won't be asked about everything, but profit is equal to revenue minus cost. Revenue is equal to the number of units times the price. Average cost, C bar, is equal to the cost function divided by x. You divide the x into the cost function. And where P is equal to profit, R is equal to revenue, C is equal to cost, little p is equal to price, and C bar is equal to average cost. Okay, so let's work a few of these. I like these. I have an MBA, so I like the business problems. Let's look at number 4, and we are on, looks like page 232. All right, number 4 says find the number of units X that produces a maximum revenue R. So we have R is equal to 600X squared minus 0.02 X cubed. So how do we find a maximum revenue? We take the derivative. So that's 1200X minus 0.06x squared. 3 times 0.02, 0.06x squared. Let's set that equal to 0. All right, we'll factor out an x, and I'd have 1200 minus 0.06x equals 0. So x is going to be 0 when that would not give us a maximum revenue. But if we set 1200 minus 0.06x equal to 0, then it would be 20,000. All right, so these critical points that we're finding can give you maxes and mins, and your min would be 0, and max is 20,000. All right, let's work number 8. So number 8, we want to find the minimum average cost, C bar, and that's going to be C is equal to 0.001 x cubed minus 5x plus 250. All right, in order to get the equation for C bar, we have to take that whole thing and divide it by x. So we divide x into each one of these. So if you do that, C bar is going to be 0.001x squared, because x cubed over x would just be x squared, minus 5x over x is just 5. And then 250 over x I'm going to write as 250 x to the minus 1, because it's easier to take the derivative. Now C bar prime be 0.002x minus 250 x to the minus 2. And we're going to set that equal to 0. All right, so that's 0.002x minus 250 over x squared is equal to 0. How could I get rid of that x squared? All right, I could multiply everything by x squared. So that's 0.002x cubed minus 250 is equal to 0. So 0.002x cubed is equal to 250. X cubed would be equal to 125,000. So take the cube root of that, and x is 50 units would minimize the average cost. All right. So we've got 2 of them down. Pause if you need to. Okay, let's take a look at the next one. Is number 12. So number 12 says we want to find the price P that produces the maximum profit, big P. We have C is equal to 2400x plus 5200, and we have P is equal to 6,000 minus 0.4 x squared. I should have put my cheat sheet stuff over to the right a little further, right? Okay, so we know that we are trying to maximize profit, so we need a profit equation. Profit is equal to revenue minus cost. We have the cost equation. Let's get the revenue equation. That's x times P. So that's x times 6,000 minus 0.4 x squared. So revenue is equal to 6,000x minus 0.4 x cubed. So now if profit is revenue minus cost, we can write that out. Revenue 6,000 x minus 0.4 x cubed minus the cost 2,400x plus 5,200. So profit is equal to 6,000x minus 0.4 x cubed minus 2,400x minus 5,200. All right, so that's going to be profit is minus 0.4 x cubed plus 3,600x, 6,000 minus 2,400 minus 5,200. Now we can take the derivative to maximize the profit. That's minus 1.2 x squared plus 3,600 is equal to 0. So I'd have minus 1.2 x squared is equal to minus 3,600. X squared is equal to 3,000. So x is equal to the square root of 3,000, which is 54.8. Let's round that up, since you don't have a 0.8 of a unit. Let's round it up to 55 units. A lot of students forget what they're doing and circle that. That's not what it asked. It asked for the price. We get the price by plugging that 55 into x there. So price is 6,000 minus 0.4 times 55 squared. So if your calculator doesn't betray you, that's 4,790. Beautiful. All right, let's do one last problem, number 16. Okay. Okay, so number 16 says use the cost function at which average cost is a minimum. And we're not going to do the second part to show the marginal cost, average cost are equal. That won't be on the test. So if I can read this, it is our cost function C is equal to x cubed minus 6x squared plus 13x. So in order to minimize average cost, we are going to have to find C bar. And that is x cubed minus 6x squared plus 13x over x. Divide x into each one, you'd have x squared minus 6x plus 13. So you do have to take the derivative. I do remember there was a student who, once they found that, then forgot to take the derivative on these business problems. Remember, this is the derivative chapter. All right, you got to take the derivative. 2x minus 6, set that equal to 0. X equals 3 units, and it just asked for the number of units. It didn't ask what the cost was. You could get that by plugging it in. All right, but that's what it asked for. And that finishes the business problems. Feel free to at least work, I would at least work a couple of these, all right, to get you back into the groove on the business problems. And, you know, I feel like maybe we need to work one more of the geometric optimization. So I'm going to flip open to page 210. I got my book handy here. I'm going to flip back to 210, and hopefully you haven't paused the video yet. And let's try number 15. And if you want to work this on your own, go ahead and do that. and then you work it on your own, and then come back to the video and see if you did it right. It says a farmer plans to fence a rectangular pasture adjacent to a river. So we've got a river, all right, and we have rectangular fencing. Let's call this X and this Y and this Y, and we want to maximize, so we want to minimize fencing, right, not maximize. So the area is 180,000 square meters. Has to be that. So you know that X times Y, because that's the area equation, has to be 180,000. All right, and we want to minimize fencing. Let's call that F. So fencing would be X plus 2Y. So we can solve for Y, that's 180,000 over X, and plug that right here. So F is equal to X plus 2 times 180,000 over X. Okay, so F, I'll go ahead and multiply that out. X plus 360,000 over X. So F is equal to X plus 360,000 X to the minus 1. So F prime is 1 minus 360,000, too many, X to the minus 2. We're going to set that equal to 0. So 1 is equal to 360,000 over X squared. So X squared is equal to 360,000. All right, so the square root of 360,000, I think, would be 600, wouldn't it? Let me check. 360,000 raised to the 0.5, 600, yeah, woo. So X is equal to 600 feet. No, it's meters. And then Y is equal to 180,000 over 600. So that's probably 300. So 600 times 300 meters. All right, and that does it. I would definitely work some more from all of these sections. Make sure that if you have questions, you ask, and happy studying.